Physics with calculus applications, and welcome to your review of graphical analysis of motion. Recall last year in physics you learned that constant motion means either an object moving with zero acceleration or an object moving with constant non-zero acceleration. Take a look at this video of two little cars. One's moving horizontally and one's moving down a ramp. First, which car is moving with zero acceleration? Which car is moving with constant non-zero acceleration? We can also sketch graphs of displacement versus time, velocity versus time, and acceleration versus time. Before you proceed with this vodcast, sketch in your notebook these three graphs for each type of motion demonstrated by the moving cars in the previous video clip. Remember, you can cheat, but I will know. What did you notice about your graphs? First, you should have noticed the graph of velocity versus time represents the slope of the displacement versus time graph, and the graph of acceleration versus time represents the slope of your velocity versus time graph. You should have also noticed that each graph represents a specific function, x of t, v of t, and a of t. Consider the power of the time, or t, in each of your kinematic equations shown right after this. Remember, these are your kinematic equations. So we've been looking at slopes of lines, slopes of functions when relating x of t, v of t, and a of t graphs. Take a look at the following graph. Clearly this is not a linear graph. It does, however, represent x as a function of t. For your homework, determine and be prepared to discuss the following. What type of motion does this function represent? How would you express this motion as a function or as an equation as a function of t? And how would you get the slope of this function? Good luck!